Notice on page 23 that you have an equation that says like x squared plus 16x plus 20. Well, that equation does not graph nicely on this graph. So, for that reason, I want you to scratch it out, and we're going to write a new equation that will look better. The new equation is negative 2x squared minus 20x minus 54. Okay, the directions say complete a table, graph, and investigate the following functions. Well, we're not going to worry about completing a table because think about it. When we graph it using our calculator, won't that generate a table for us? We can just do second table and we'll have a table. So there's no reason for us to hand draw a table over here. That's just a lot of unnecessary work since we have graphing calculators that will create a table for us. So the first thing we need to do is graph it. So you'll go to your calculator, go to y equals, clear out whatever's there from last period, and now type in your new equation, negative 2x squared minus 20x minus 54. Okay, so the first thing we're doing is graphing it. Now, you'll notice on your calculator screen that we see it all in the third quadrant, correct? Quadrant 1, 2, 3, 4. So it's mostly in quadrant 3. Now, eventually, this one will probably run into quadrant 4, right? Because it'll continue as it goes down. It'll continue moving to the right. And so eventually, this part of the parabola is going to go into quadrant 4. But right now, that's all we see, which is why on your paper, it's really zoomed into quadrant 3. So we see the gist of it, but to actually get some points to plot over here to make our parabola accurate, where do we find the points? The table. If we hit second and then table, which is the word above graph, look, it gives you a bunch of points. Now, it might pop up right away to some points that we're not going to be able to fit on this graph. Think about it. Isn't every single part of the parabola going to have a negative x value that we're going to plot anyway? So when you go to the table, maybe you should go to the negative x values. Okay, negative 1, negative 36. We're not going to be able to plot that because negative 36 is too far down. Negative 2, negative 22 is going to be too far down. But then the next one we get to, negative 3, negative 12. You can fit that one on there. So go ahead and plot the point negative 3, negative 12. Yes, okay, and once you plot that, go back to your table and keep going to the negatives, and then there's another nice point, negative 4, negative 6. So left 1, 2, 3, 4, down 6. 1, 2, 3, 4, 5, 6. And then if you continue going left, negative 5, negative 4. So left 5, down 4. Okay, then another nice point is negative 6, negative 6. So left 6, down 6. And then negative 7, negative 12 would be left 7, down 12. Okay, so 5 points is sufficient. Now you can connect those 5 points to make your parabola. Why is it that our parabola opens down? That negative out front. Well, the negative is what causes it to open down. What did the 2 cause to happen? It got skinnier. It's a vertical stretch. Okay, now we're going to talk about some characteristics. Domain. What do you think of when you hear the word domain? X value. So like how far the graph will go left and how far the graph will go right. So what is the domain? Correct. As you go down, it'll also go left forever, and as you go down this side, it's also going right forever. Now, it's slowly moving left and right, but it will continue to do that forever. So when you hear the word range, what do you think about? The Y's. Now, one thing that's hard for students to remember, they normally can remember domain is left and then right. But then it's harder for them to remember that when you're doing the range, you see how far down it goes first, and then how far up it goes. So how far down will this parabola go? Forever down, which will be negative infinity, correct? How far up can you go? Right, there's the highest point, and it is at negative 4 on the y-axis. And it stops there, so yes, you put a bracket. Okay, now zeros is kind of a new word for us. It just means x-intercepts. Does this graph have any x-intercepts? All right, zeros is another word for x-intercepts. Will this parabola ever cross the x-axis? Yeah. No, because it starts here and then it goes down on both sides forever. So it's never going to come back up and hit the x-axis. Okay, so for this one, we don't have any zeros. Do not exist, or you could write none. Both of those answers are acceptable. What's not acceptable is like 0. Because if you write 0, that tells me that you think this graph's going to cross the x-axis at 0, and it doesn't. Okay, y-intercept. We all know what a y-intercept is. Do we currently see it on the graph that we've graphed? No, but don't we know that eventually it's going to come down and hit the y-axis somewhere way down there? How can you easily find it? The table. What are you looking for in the table? Where x is 0. Because when x is 0, it's sitting directly on the y-axis. So what's the y-intercept? Negative 54. And you write it as a point. 0, negative 54. Okay, interval of increase. Now, keep in mind, we read from left to right, and intervals, we only care about the x values. So which side of that parabola is increasing? The left side or the right side? The left side. From left to right, this part's going up, correct? Well, when did it start going up? Negative infinity. Because, remember, we only care about x values. Isn't that to the left? So that's why it's negative infinity. And didn't it keep increasing until it got to this point, which has an x value of negative 5. Remember, we only care about the x values when we're doing the intervals. Okay, well, if it quit increasing at negative 5, wouldn't that be the place where it started decreasing? And then from there, didn't it go, even though it's going down, we don't care about down, because we care about x values. It's going to the right, which is positive infinity. Okay, does this parabola have a max point or a min point? A max. It has a highest point, and where is that highest point? Negative 5, negative 4, right? The vertex. So for minimum, you can just write none or does not exist. It'll continue going down forever and ever, so even if you tried to say that's the lowest point, it's just going to keep going. All right, end behavior. Remember with end behavior, they'll always give you this part. They'll say x approaches infinity, x approaches negative infinity. Sometimes they might write it flip-flop. You just have to read it so you'll know. And then you have to tell what y approaches. Well, what does x approach infinity literally mean? Well, it is positive, and the x-axis only runs two ways, left and right. So would this be left or right? So if you're on that parabola and you go to the right side of it, you go down. So y would approach negative infinity. So if this means right, wouldn't that mean left? Well, if you go to the left side of the parabola, you go down. With parabolas, their end behavior is always going to match. They're either both going to go up or both going to go down, which makes it an even graph. Okay, when the end behavior is the same, it's an even graph. Okay, now for B. I'm going to, I want you to scratch out the equation that's there, because it doesn't work out nicely with that graph, and I'm going to give you a new one, and I want you to try this example by yourself before I do it for you. Okay, is everybody finished copying these? Okay, so scratch out the one that's there and write in this new one. 1/2 x squared minus 6x plus 18. Now before you get started, you should be able to tell me two things already about this parabola. Can anybody tell me one of those two things? It's going to open up and it's going to shrink. How do we know it's going to open up? How do we know it's going to open up? There's not a negative out front. If there's a positive number in the front, it's going to open up. And how do we know it's going to shrink? There's a number less than 1 in the front. Okay, so go ahead and try this one. Graph it and then answer all those questions and then we'll go over it. Correct. It will go left forever and right forever. What about the range? 0 to positive infinity. Good one. Think about it. Its lowest y value is right there, which is a y value of 0. And it stops there. But then you can go up forever, so infinity. Okay, does it have any zeros, any x-intercepts? Yeah, it has 1, and where is that 1 located? 6, 0, which is also the vertex of this parabola. Okay, does it have a y-intercept? Is it 18? Okay, to find it, you would have to go to your table and look for what? Where x is 0. Okay, interval of increase. Isn't it increasing from the vertex up the right side? So when did it start increasing? 6, because you only use the x value, and then it increased forever to the right, which is positive infinity. Well, it decreases on the other side, so when did it start decreasing? Negative infinity, because even though it's going up, we don't care about up and down. We only care about x values, left and right, and this one's left. So negative, and then when did it quit decreasing? 6. Is there a max or a min for this one? A minimum. So no max, because it goes up forever. And where is that minimum? Right. It's the vertex and the x-intercept. They're all the same place. Okay, end behavior. No matter which way you go, right or left, your y values are all going to approach positive infinity. It goes up on both sides, so it's even. Okay, now go to page 24 and try letter C. That equation's fine, so you can try that one. The first thing you have to do is graph it on the calculator, so put it in and hit graph. Okay, there it is. To plot it on your... To put it on your graph paper, go to the table and pick out some nice points. Okay, 0, 6 is good. And then another nice point would be 1, 2, 2, 0. And then another nice point is 3, 0, and then 4, 2. And then 5, 6. Okay, now, we run into a small problem here because our two lowest, or our 2 points down here are the same value, the same y value. Well, with a vertex, it has to be the absolute lowest point. So technically, your vertex is about right here, right below them. Now, the reason that we don't see that point in our table is because normally your table is set up to only go by whole numbers. See how all of these are whole numbers? But, like I was saying a while ago, right here in blue it says table set for table settings. You can change that. If you hit second and then table settings, I can go by quarters, 0.25, instead of ones. And now when I go back to my table, now look. Okay, look up at the board. There's 2, 0, which I already plotted. And there's 3, 0, which I already plotted. But then there's 3 coordinates in between them. Isn't 2.5 down 0.25 the lowest point? So, and think about it. Doesn't that, where I put that red, look exactly over 2.5 and then down a quarter? So that's your vertex. The reason it didn't show up on your table, though, is because your table normally jumps by whole numbers. You have to change it to jump by decimals if you want to. Okay, so now that we have that, let's talk about the characteristics. What is the domain of this parabola? Correct. It'll go left forever and right forever. What is the range? How low does it go on the y-axis? On the y-axis? Negative 0.25. Remember that vertex went down 0.25 and that's the lowest it'll get on the y-axis. And it stops there. How high will it get? Infinity. Okay, does it have any zeros? Does it have any x-intercepts? Yeah, it has 2 of them, right? Didn't it have one at 2, 0, and it had another one at 3, 0? Does it have a y-intercept? Where is it? 0, 6. Okay, it's increasing on the right side. So from the vertex, and up. Well, what was the x value of the vertex? 2.5. That was the y value of it. The x value was 2.5, so it goes from 2.5 to infinity for increasing. So where would it be decreasing? Negative infinity to 2.5. Does this one have a max or a min? Guys, does that parabola have a max point or a min point? A minimum point. So for maximum, you can just write none or does not exist. Where is the minimum point? 2.5, negative 0.25, right? The vertex is the minimum point. Okay, for end behavior. No matter which way you go, right or left, you will always be going which way on the y-axis? Up. Okay, because the parabola is opening up, which makes it even because they behave the same way. Okay, letter D, I'm going to change that equation, so go ahead and scratch out the current one. Okay, and so now your equation is negative x squared plus 7. Go ahead and try that one. Before I even graph it in the calculator, though, I can already tell you two things about this parabola. What are the two things that I can tell you about it? It's going to open down. No, because that's a 1, which is the standard size. It's not going to be a shrink or a stretch. That plus 7 on the end tells me that it's going to shift up 7. Okay, look when I graphed it. Didn't it go up 7? And then it opened down? Okay, to get some of the other points on it, I'll go to the table. Mine's set to 0.25s. I'll just leave it there for now. So let's say 1, 6 is a nice point. Right 1 up 6. 2, 3. 3 negative 2 won't really fit because you can't go down 2. So let's go the other way and get some points over here. 0, 7. Negative 1, 6. And then negative 2, 3. Okay? So then we can draw our parabola. It opens down because of the negative. It shifted up 7 because of the plus 7. And it didn't shift left or right. Okay? That's why it looked different than all the other ones we've been doing, because there was no horizontal shift. So what is the domain? Negative infinity to positive infinity. Okay? Every parabola you do will have that domain. What is the range? Negative infinity to 7. Good. It'll go down forever, but then the highest it will get on the y-axis is right there, which is a y value of 7. Does it have any zeros, otherwise known as x-intercepts? Well, what are you looking for in the table when you're trying to find an x-intercept? Where y equals 0, right? Because to sit directly on the x-axis means it didn't go up or down, so the y would be 0. So let's go until we see y is 0. We don't really see it, do we? Okay, but it does cross it 2 times. But what this means is it's just not crossing at an interval of 0.25. You know how my table is set to go by 0.25s? Like if I change it and go by like 0.1, let's see if we can find it. Okay, so now let's go to the table. And now let's see if we can find a y value of 0. It's getting closer, but it's still not landing exactly on 0. So you can tell about where it would be, but we don't know for sure. Okay, yeah, it'd be very close to negative 2.65. So since this one's harder to find, we'll just write down that there are 2 zeros. And then think about it. With multiple choice, wouldn't you be able to make an educated guess where it's crossing the x-axis? Okay, y-intercept. 0, 7. Interval of increase. Which side of the parabola is increasing? The left. When did it start increasing? Negative infinity, because left is negative and forever is infinity. When did it quit increasing? 0. X values only. That 7's a Y value. So if it quit increasing at 0, doesn't that mean that's where it starts decreasing? And then it decreases forever to the right, which is positive infinity. Okay, is there a max or a min for this problem? A max. So the min doesn't exist because it goes down forever. And where is that max? 0, 7. The vertex and the y-intercept is also the max. In behavior, as x approaches infinity, y approaches negative infinity. As you go right, you go down. As x approaches negative infinity, y approaches negative infinity. If you go to the left side, you still go down, which makes it even. Okay, you can switch out. Tomorrow we'll start reviewing for the test. I can do stamps today and tomorrow. I'm taking up your pink sheet Monday when we finish the review, and the test is Tuesday.